Hello everyone, I, Matthias Banat and Ludwig Granström worked this summer under the guidance of Jonas Geller on the physical modeling of waves and ship motion. The end goal of the company Jonas Geller with this work is to further improve their simulations of UEVs landing on a moving ship moving above water. So what we achieved under the course of the 6 weeks of work can be summarized as a threefold result. So firstly, a mathematical model for the simulation of waves, a mathematical model for the ship motion model, and finally, as you can see right over here and right over here, some visual simulations in MATLAB. So over to the first concept, wave modeling. Waves are modeled as superpositions of harmonic waves of distinct frequencies and phases. The first important concept when modeling waves is the power density spectrum, which is chosen according to the properties of the sea that which it should be simulated. In our case, we chose the Brett-Schneider spectrum, which is known to describe well the waves of the North Atlantic Ocean. A second important concept when modeling waves is the concept of sea state. It is a metric modeling the wave heights and goes from 0 for a very glassy sea to 9 for an agitated sea. The equation here presented describes the wave amplitude at a coordinate xy at a certain time t. It is a sum over all the wave frequencies and the m spatial angle differences from the defined main wave. A visual simulation of this can be seen right above here for waves of sea state 2 and waves of sea state 4. Good. Over to the second thing, which is the ship motion model. The suggested ship motion model, represented by this equation right over here, is a simplified version of the model suggested by Tore Fossen, which is a non-researcher in the field of marine robotics in Norway. The motion model describes the translation of the center of gravity of the ship and the rotation around the center of gravity of the ship. Good. The forces taken into account when modeling the movement of the ship are the hydrostatic pressure of the sea, the viscous damping force, the weight of the ship, and the Coriolis force. Therefore, forces such as the dynamic pressure from the sea, added mass, and wind forces are ignored. So this makes our model more simpler than the model by Tore Fossen. Finally, over to the results. Here we can see the simulation of the waves, of unidirectional waves, and the ship moving around above the waves. Down here, we see a plot over all the 12 states of the ship when on those unidirectional waves here above. For videos and a more extensive report, please follow this Git repository through this QR code. Thank you for your attention and see you next time.